Alright, in this video we're going to continue on with the Sherpa fitting, and we're going to do some 2D modeling. Um, Basically 2D fitting. So we're going to start with this source here, and we're going to, let me actually zoom in here a little bit. We're going to just try to model this as a 2D Gaussian. It's not very Gaussian, like you can see. All kinds of structure and stuff in here, but we'll try anyway. So I'm going to region, draw a circle around here, analysis DAX, sherpa, and 2D fitting. So we have a couple of different 2D profiles we can fit. Gaussian beta, I can't say that word. They're NC and 2D, so we're just going to go with the Gaussian. And I haven't subtracted any background or anything, so I'm just going to leave a constant term in here, a flat background basically. You can either do a constant or a polynomial. Confidence intervals take a long time to run, so I usually don't set those. Method we'll leave alone, statistical leave alone, and we'll go ahead and do the fit. So it's gone off and it started Sherpa, it's extracted this data, and it's guessed these model parameters. The background here is definitely off, so we'll change this to be 1. Amplitude 640, if I look at the value here, that's not too horrible, I'll guess. Centroid, 3817, 3817, so that looks pretty good. So we can then fit, and we get the, so this is the original data, this is the model, and then this is the residuals. And the residuals usually look best when you do a linear scale. You can see basically this is the result of this minus that kind of thing. And that's kind of basically it for 2D fitting. You can, like I said, you can play around the different profiles. Otherwise, that's pretty much the extent of it.